Hi everyone, welcome back. Today we're going to be looking at 7.rp.a.2a. Decide whether two quantities are in a proportional relationship by testing for equivalent ratios in a table or graphing on a coordinate plane and observing whether the graph is a straight line through the origin. So for today's lesson, we're just going to focus on identifying if a relationship is proportional from a table. In order to tell from a table if there is a proportional relationship, you can check to see if the ratio of y to x is the same for each set of values in the table. The ratio y to x is also known as the constant of proportionality, and you must reduce the ratios to accurately compare. So let's go ahead and take a look at our first table. So we're going to compare the ratios from y to x. So for the first example, I'm going to write that as 10 to 5, which can be simplified. 5 goes into itself once, 5 goes into 10 twice. So it can be simplified 2 to 1. Now let's take a look at 16 to 8. This can also be simplified. 8 goes into itself once, 8 goes into 16 twice, so the ratio again, 2 to 1. 20 to 10, 10 goes into itself once, 10 goes into 20 twice, so 2 to 1. The ratio of 28 to 14, 14 goes into itself once, 14 goes into 28 twice. And then last but not least, 42 to 21. 21 goes into itself once, 21 goes into 42 twice for a ratio of 2 to 1. So we can rewrite these ratios using our fraction bar. And if you notice, all of these ratios, when simplified, are equal. So they're all equal to the ratio of 2 to 1. So what we would say here is that yes, this is a proportional relationship. And that the constant of proportionality is 2 to 1 or 2. Okay, so again, yes, this relationship is proportional, and the constant of proportionality is that simplified ratio of 2 to 1 or 2. Let's take a look at another example. So we're going to start off again, y to x, and we're going to simplify. So here we have y as 9 and x is 6. So 9 to 6, which can be simplified. 3 can go evenly into 6 and 9, and that would give us 3 to 2. Now we have 15 to 10. The largest number that goes evenly into both is the number 5. 5 goes evenly into 10 twice, into 15 3 times. So here we have, again, 3 to 2. Then we have 20 to 4. The largest number that goes evenly into both is the number 4. 4 goes into itself once. 4 goes into 25, so that's a ratio of 5 to 1. Then we have 21 to 14. The largest number here is 7. 7 goes into 14 twice. 7 goes into 21 3 times. So 3 to 2 is the simplified ratio. And then 44 to 22. 22 goes into itself once. 22 goes into 44 twice for a ratio of 2 to 1. So here, unlike the previous example, we have equivalent ratios in 3 places, but in 2 places it is not equivalent. And therefore, this is not a proportional relationship because all of the ratios are not equal. So again, this is not a proportional relationship because the y to x ratios are not all equal. Let's take a look at these next 2 examples. This is a good place to pause and try these 2 examples on your own. So again, we're looking at the y to x ratio, and it needs to be simplified. So here we have 4 to 1, which is in its simplest form. Then 8 to 2 can be simplified. 2 goes into itself once. 2 goes into 8 4 times, so that's simplified 4 to 1. 9 to 3, 3 goes into itself once, 3 goes into 9 3 times, so this ratio is 3 to 1. So here we have 2 out of the 3 ratios that are equivalent, but this third one is not. Therefore, this is not proportional. Let's take a look at the next example. So again, it's a y to x ratio. 6 to 4 can be simplified. 2 can go evenly into both of these numbers. 2 goes into 4 2 times, 2 into 6 3 times. So that gives me a ratio of 3 to 2. 9 to 6 can be simplified. 3 goes into 6 twice. 3 goes into 9 3 times for a ratio of 3 to 2. And then 15 to 10 can also be simplified. 5 goes into 10 2 times, 5 into 15 3 times. So here we find that all 3 ratios, when simplified, are equivalent. Therefore, this relationship is proportional. And what would be the constant of proportionality? The constant of proportionality would be 3/2. Thank you for watching and have a great day.